Hi everybody and welcome to OSI Model. Let's begin. The OSI model, or Open Systems Interconnection Model, is an absolute fundamental model used in networking. This critical model provides a framework dictating how all network devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions and designs on a network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer that data travels through, specific processes take place and pieces of information are added to this data, which is what we'll come to discuss in the upcoming task within this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model looks like in the diagram below. Okay, and now let's answer the questions. What does the OSI in OSI model stand for? And that will be Open Systems Interconnection. Okay, so let's type that in. So Open Systems Interconnection. Let's see. And submit. Great. How many layers in digits does the OSI model have? And that will be 7. Submit. What is the key term for when pieces of information get added to data? And that will be encapsulation. Great. And now let's move on to the next task, which is application. The application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Everyday applications such as email clients, browsers, or file server browsing software such as FileZilla provide a friendly graphical user interface, or GUI, or also known as GUI, for users to interact with data sent or received. Other protocols include DNS, or Domain Name System, which is how website addresses are translated into IP addresses. Okay? And yep, let's now answer the questions that we have right here. So what is the name of this layer? And that will be application. Great. And what is the technical term that is given to the name of the software that users interact with? And that will be graphical user interface. Awesome. And now let's move on to the next task, which is presentation. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as an email client, differently, the data still needs to be handled in the same way, no matter how the software works. This layer acts as a translator for data to and from the application layer, layer 7. The receiving computer will also understand data sent to a computer in one format destined for in another format. For example, when you send an email, the other user may have another email client to you, but the contents of the email will still need to display the same. Security features such as data encryption, like HTTPS when visiting a secure site, occur at this layer. Okay, and let's answer the questions. What is the name of this layer? And that will be presentation. So let's type that in. And what is the main purpose that this layer acts as? And that will be translator. Great, and now let's move on to the next task, which is session. Once data has been correctly translated or formatted from the presentation layer, layer 6, the session layer, layer 5, will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. Whilst this connection is active, so is the session. The session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before data is sent and received. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks, packets, one at a time. This dividing up is beneficial because if the connection is lost, only the chunks that weren't yet sent will have to be sent again, not the entire piece of data. Think of it as loading a save file in a video game. What is worthy of noting is that sessions are unique, meaning that data cannot travel over different sessions, but in fact only across each session instead. Okay, and now let's answer the questions. What is the name of this layer? And that will be session. What is the technical term for when a connection is successfully established? And that will be session once again. And what is the technical term for small chunks of data? And that will be packets. Great, and now let's move on to the next task, which is transport. Layer 4 of the OSI model plays a vital part in transmitting data across a network and can be a little bit difficult to grasp. When data is sent between devices, it follows one of two different protocols that are decided based upon several factors. And those protocols are the TCP protocol and the UDP protocol. So let's begin with the TCP protocol, which stands for the Transmission Control Protocol. Potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. This protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Error checking is how TCP can guarantee the data sent from the small chunks in the session layer, layer 5, has then been received and reassembled in the same order. Let's summarize the advantages and disadvantages of TCP in the table below. Okay, so first, guarantees the accuracy of data. Requires a reliable connections between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. Capable of synchronizing two devices to prevent each other from being flooded with data. A slow connection can bottleneck another device as the connection will be reserved on the receiving computer the whole time. Performs a lot more processes for reliability. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because these services require the data to be accurate and complete. No good having half a file. In the diagram below, we can see how a picture of a dog is broken down into small pieces of data, known as packets, from the web server, where the computer reconstructs the picture of the dog into the correct order. Okay, let's take a look. All right. Now let's move on to the User Datagram Protocol, or UDP for short. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. There is no synchronization between the two devices or guarantee. Just hope for the best and fingers crossed. Whilst this sounds disadvantageous, it does have its merits. which we'll lay out in the table below. So first, UDP is much faster than TCP. UDP doesn't care if the data is received. UDP leaves the application layer, user software, to decide if there is any control over how quickly packets are sent. It is quite flexible to software developers in this sense. UDP does not reserve a continuous connection on a device as TCP does. This means that unstable connections result in a terrible experience for the user. Okay? Using the same example as before, we can now see that only packets 1 and 3 have been received by the computer, meaning that half of the image is missing. Yes, and we can see the final result here. UDP is useful in situations where there are small pieces of data being sent. For example, protocols used for discovering devices, ARP and the HCP that we discussed in room number 2, called Intro to LAN, which, by the way, I have a walkthrough of that room, so if you haven't seen it yet, go check that out. Or larger files such as video streaming, where it's okay if some part of the video is pixelated. Pixels are just lost pieces of data. Okay, and now let's answer the questions. What is the name of this layer? And that will be transport. So transport. Submit. What does TCP stand for? And that will be Transmission Control Protocol. What does UDP stand for? And that will be User Datagram Protocol. What protocol guarantees the accuracy of data? And that will be TCP. What protocol doesn't care if data is received or not by the other device? And that will be UDP. What protocol would an application such as an email client use? And that will be TCP. What protocol would an application that downloads files use? And that will be TCP. What protocol would an application that streams video use? And that will be UDP. Great, and now let's move on to the next task, which is network. The third layer of the OSI model, network layer, is where the magic of routing and reassembly of data takes place, from the small chunks to the larger chunk. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. While some protocols at this layer determine exactly what is the optimal path that data should take to reach a device, we should only know about their existence at this stage of the networking module. Briefly, these protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. The factors that decide what route is taken is decided by the following. What path is the shortest, that is, has the least amount of devices that the packet needs to travel across? What path is the most reliable, that is, have packets been lost on that path before? And which path has the faster physical connection, that is one path using a copper connection slower or a fiber considerably faster? At this layer, everything is dealt with via IP addresses such as the one that we see on the screen. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices because they're capable of working at the third layer of the OSI model. Okay, and now let's answer the questions. What is the name of this layer? And that will be network. So we type in network. Let's see, network, submit. Awesome. Will packets take the most optimal route across a network? And the answer is of course yes. What does the acronym OSPF stand for? And that will be Open Shortest Path First. Open shortest, let's see, shortest path first. There you go. And what does the acronym RIP stand for? And that will be Routing Information Protocol. Okay, so let's type it in. Routing Information Protocol. Great. And now, what type of addresses are dealt with at this layer? And the answer is IP addresses. So IP addresses. Submit. Great. And now we can move on to the next task, which is data link. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC address of the receiving endpoint. Inside every network-enabled computer is a network interface card, or NIC, which comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can be changed, although they can be spoofed. When information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission. What is the name of this layer? And that will be data link. Great. And what is the name of the piece of hardware that all network devices come with? And that will be network interface card. Great. And now let's move on to the next task, which is physical. This layer is one of the easiest layers to grasp. Put simply, this layer references the physical components of the hardware used in networking and is the lowest layer that you will find. Devices use electrical signals to transfer data between each other in a binary numbering system, ones and zeros. For example, Ethernet cables connecting devices, such as in the diagram below. Okay, and now let's answer the questions. What is the name of this layer? And that will be physical. And what is the name of the numbering system that is both zeros and ones? And that will be binary. And what is the name of the cables that are used to connect devices? And that will be Ethernet cables. I'm sorry, I didn't type into the put field. I apologize. Let's try again. There you go. And let's move on to the next task. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff high score of 19 seconds? Click the view side button on the right to start. Okay, so our hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right and the space bar to enter doors. Okay, so let's begin. Play. Okay, let's see. First will be physical. And then data link. And then network. Then transport, and then session, then presentation, and finally application. Well done, you escaped the dungeon, completed in 27.65 seconds, and the flag is the one that we see right here, which I can just copy and I'll use it to answer the question. Escape the dungeon to retrieve the flag. What is the flag? And here you go. Submit. Perfect. And now let's move on to the next task. And of course, there's nothing here, so I can just click on complete it. And we are done with this room. Okay, everybody, I hope you enjoyed the video, found it helpful. If you did, give it a thumbs up. I would really appreciate that. And of course, subscribe to the channel for more videos on TryHackMe. Okay, talk to you next time.